Assalamu alaikum wa rahmatullah. Welcome back to our chemistry class, SS1, prepared by Abdulkadir Hamza. Today we are going to see salt. Salt is divided into two. We have soluble and insoluble salt. So we are going to see both of them today, inshallah. Soluble and insoluble salt. All trioxynitrate 5 are soluble in water. When we say soluble, we mean react when we react it with water, it will dissolve completely. We cannot see the salt inside the water. So that is what we mean by soluble. Insoluble, well, even if we dissolve it in water, we'll still see the salt inside the water. That means we can say sparingly soluble or soluble in water. So all the trioxynitrate are soluble in water. When you dissolve like trioxynitrate, all the trioxynitrate are soluble in water. All tetraoxosulfates are soluble except barium sulfate, calcium sulfate, lead sulfate. That means salt of barium, calcium, and lead are insoluble in water. So all chlorides are soluble in water except lead chloride, silver chloride, potassium, sodium, ammonium salt are generally soluble. So all trioxynitrates are insoluble except calcium carbonate, sodium carbonate, ammonium carbonate, which are soluble. All metallic oxide insoluble except calcium oxide and sodium oxide. So these are soluble and insoluble salt. We are going to see how to prepare insoluble salt. Insoluble salt example: barium sulfide, calcium sulfide, lead chloride, and silver chloride. Most trioxocarbonate 4 can be prepared by reacting compound containing the wanted cation, that means the metal, with another compound containing the wanted anion, that is the non-metal. So this is precipitation reaction, e.g. preparation of barium sulfate. First, barium chloride, since it contains wanted barium, that is, it contains the metal, barium metal, react with calcium sulfate. Since calcium sulfate contains anion, that is the wanted anion, tetraoxosulfate 6 ion to produce solid barium sulfate and aqueous potassium chloride. Barium sulfate is separated from calcium chloride by filtration, leaving the filtrate of calcium chloride and barium sulfate left on the filter paper. Is washed with water to completely remove calcium chloride. Calcium chloride and filter paper is squeezed with another filter paper to dry. So when it dry, what is inside, what will stick on the filter paper is barium sulfate. What we washed out, since calcium chloride is soluble in water, so what goes with water is calcium chloride. Preparation of Soluble salt. By neutralization, we can prepare soluble salt by neutralization. Example, reacting zinc with tetraoxosulfasis acid to prepare tetraoxos zinc tetraoxosulfate. Zinc metal is reacting with tetraoxosulfasis acid to give zinc sulfate and water. That is, we have had that neutralization reaction is a reaction between the acid and the base. So here, zinc metal uh, zinc metal act as a base. Since what 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 we obtain is salt and water. Zinc is added to tetraoxosulfasis acid until in excess to ensure no more tetraoxosulfasis acid is present. Then the mixture is filtered off to separate zinc from zinc sulfate. The filter, that is the zinc oxide, is then placed in evaporating dish to evaporate most of water. Then it's cooled after zinc sulfate crystal are formed. Then the crystal then filter and squeeze between the filter paper to dry. So neutralization reaction is easy to separate since it forms salt and water. So we can evaporate the water by heating. We can separate the water from the zinc sulfate by heating. As we heat the solution, then the water will escape and give us the clear solution of zinc sulfate. So by reacting insoluble base with acid, in our previous lesson, we have seen soluble and insoluble base. So reacting magnesium oxide with acid. Magnesium oxide is a base, insoluble base. So when we react it with acid, it will give magnesium sulfate and water. So this one, so we can also separate we can also obtain our clear solution of magnesium sulfate by evaporating the solution to escape the water. So by reacting trioxocarbonate 4 with acid. Example, reaction of potassium carbonate with acid. It will give calcium sulfate, carbon 4 oxide and water. So carbon 4 oxide is a gas. We have water. We can separate the solution with the carbon 4 oxide and the water easily. The same process is used as a reaction of acid with beta. Just that carbon 4 oxide is produced. The gas produced can be tested by bubbling it into a lime water, which will turn colorless lime water into milky. So when we test we can test the presence of carbon 4 oxide by reacting the before that is given out with a lime water. So lime water is colorless. When it react with carbon 4 oxide, it will turn to milky. Uses of salt. Salt has long been used for flavoring and preserving food. So in those days, salt are used in many processes. So they are being used for flavoring agent and the preserving agent. We have seen it. It has also been used in tanning, dyeing, and bleaching. and protection of poultry, salt and chlorine. So these are the uses of salt. Today is widely used in the chemical industry. Okay, let's look at some different types of salt that have natural, can we say natural properties. So there are some salt when you cannot keep it under air. Some can absorb air from the atmosphere. Some can give out water. Some can absorb water from the atmosphere. Some can give water out to the atmosphere. So we have what we call hygroscopic. We have the liquescent and a fluorescent substance. Hygroscopic substances are capable of absorbing water from the air and not dissolving in it. Silica gel, concentrated hydrosulfuric acid, magnesium carbonate, calcium carbonate. So, sorry, these are substances. It may be acid, base, or salt that has some unique property. When you keep it open, some may absorb, some may keep out water. For example of this, when you open concentrated tetraoxosulfuric acid, it will absorb air, it will absorb water from the atmosphere. So, as we see, the air, it contains many things. It contains hydrogen, it contains oxygen, it contains nitrogen, it contains carbon dioxide, it contains carbon 2 oxide. So these substances, they are capable of absorbing water. It also contain water vapor. So these chemicals are capable of absorbing the air moisture to dilute itself. When you give concentrated hydrochloric concentrated hydrosulfuric acid open, it will absorb water from the atmosphere. So the only way you can understand this chemical have absorbed water from the atmosphere, you can measure the quantity. So when you put some amount of concentrated tetraoxosulfuric acid or magnesium carbonate or calcium carbonate in a container, they don't come. When you come back after some hours or some days, you measure it again, you see it has increased because it absorbs something from the atmosphere. So also silica gel. Then we have the liquescent substance. The liquescent substances are capable of absorbing moisture from the atmosphere and dissolve in it to form a solution, e.g. anhydrous calcium chloride, magnesium chloride, copper nitrate, sodium hydroxide pellet. So the difference between the hygroscopic and the liquescent, they are absorbing water from the atmosphere, but hygroscopic absorb water and not dissolve in it. The water it absorbs will not dissolve in the, will not make the substance to dissolve. But the liquescent substance, when it absorbs water, in it, it forms a solution. When you expose sodium hydroxide pellet on air, you see it is turning the substance to a solution. It will react to water with the atmospheric water to form a solution. So also when you are reacting copper nitrate and anhydrous calcium chloride and magnesium chloride. Then we have what we call efflorescence. These are capable of losing their water of crystallization when exposed to atmosphere. So the difference of what is the difference between this? This is your opposite of the bond. The hygroscopy and the liquid are absorbing water, while efflorescence is losing water when exposed to the atmosphere. When you bring sodium carbonate, the carbohydrate, when you leave it open, for instance, you measure some amount of this salt, you expose it to air. When you come back, you measure it again, you reduce in the quantity because it has lost some water into the atmosphere. We have magnesium sulfide heptahydrate, copper sulfate pentahydrate. These all these are capable of losing uh, water to the atmosphere. So this is the end of today's lecture. We shall meet in the next class. Thank you for listening.